So good morning, everybody. I'm going to present some of the results about the predictability of air temperature over Europe that we carried out with some colleagues from IPSL Océan, EPOC, and Climate Data Factory. And in particular, I'm going to focus on the on the detection of the so-called windows of opportunity for statistical bias IPSL decadal prediction. That is the detection of some context, of some specific context in which the prediction, the decadal prediction system perform better. So to start, I briefly introduce the IPSL decadal prediction system. As Paco already mentioned, there are two operating versions of the decadal prediction system. The CM5, which relies on 3 members initialized every year through anomaly temperature SST anomaly nudging, and the CM6 version that relies on 10 members with initialized every year with SST and SSS anomaly nudging. So for this study, I used the CM5 version that already shown good skill in predicting SST and AMV as well as DMC. And moreover, for this study, I've used the bias simulation. Was adjusted data were provided by the Climate Data Factory, and are based on the cumulative distribution function transform, which is a variant of the quantile method, and is based mainly on multiply learning periods. So there are 2 different observational data used for the calibration. The first one is the NOAA reanalysis data that Didier last year has already introduced in Venice, and he showed that there is a slight improvement of the bias of the skill of the bias data with respect to raw data, at least for lead time 1-3. And nevertheless, however, I use the bias data calibrated with watch reanalysis data, and that I can show here show more or less the same features in terms of improvement. There are 2 possibilities. There are 2 grids in which the bias data can be projected. So I will use the IPSL grid for our evaluation analysis, but there is also the possibility to use the watch data on higher resolution for example, for impact analysis. So the main question behind our study is are there any specific context or condition under which the DCPP system perform better? Answering to this question, implies a comprehensive overview of the potentiality that can be very useful in terms of climate service, for example, because it can inform, for an optimal development of a climate service that can inform end users and stakeholders from many fields, from agriculture to water management, etc. So to try to answer to this question, we systematically calculated the skill through ACC and RMSE of the detrended air temperature indicast with respect to the trended NOAA analysis data, and we did it for all the possible combination of consecutive months, for all the possible combination of consecutive lead times LT, and for all the combination of period with lengths of 26 years, 35, and 44 years. So in this way, we obtain a three-dimensional matrix of more of 200,000 skill values, and in order to establish a reference context, we fix it to be the one including all the months of the year, with lead time 1.5, and with the first year for each of the combination of period. So fix this reference context. We can start by analyzing their skill for defining air temperature over Europe. We can see that for all the periods, all the lengths of the period that we consider, we have a good skill, especially in UK and the eastern part of Mediterranean sector, while there are no skills in over Iberia, over the northeastern part of Europe. And so now fix this reference analysis. We can see what happens when we when we vary the lead time, the months, and the periods. And I did systematic calculation of the ACC and RMSE for this region controlled by black box. So let's start to analyze what happened when we just vary the period and we fix lead time and months. We can see that there is that the skill varies with different period considered. So the skill is function of it's a function of the period selected, and a first consideration that we can do is that the best ACC that does not always correspond, apart from the case with lambda equal 44 years, the ACC doesn't correspond to the lowest RMSE. Nevertheless, both the metric vary consistently among them over a certain range. That here, for example, for the ACC, if we see the best correlation and the worst correlation, there is a gap of 0.28. So now we are going to in turn vary the lead time and the months. But before analyzing these figures, maybe it's better to focus on the x-axis of these two plots that can be a bit tricky. So for the lead time axis, there are on the lead time axis there are all the 55 combinations of possible lead time that have been sorted such that we start with all the combination starting from lead time 1, so lead time 1, 1, 2, 1, 3, 1, 4, and so on until 110. Then we continue with all the combinations starting with lead time 2, and so on until lead time 10. The same for the months. There are all on this axis. There are all the 78 possible combinations, and that have been sorted such that we start from all the combination, including January, starting from January, sorry, and then all the combinations starting from February and so on until December. So I know that is a bit tricky, so I left in each slide in which there is this this axis. I left this reminder on the bottom right part of the slide. And so if we analyze these plots, we can see that the skill in function of lead time, of varying lead time, on varying months, there is a strong dependence on them, even more than what we found for the periods. And if we compare the range between, for example, between the maximum ACC and the minimum ACC for the simulation, for the configurations where the months are varying, we have a gap of almost 1.0, while for the configuration where the periods was varying, we had a gap of 0.28. So in order to have a wider vision of what happens by varying all these independent variables, we now mutually vary two of these three independent variables. So in the first map we have just fixed the period. In the second one we have just fixed the lead time, and in the third one we have just fixed the months. And what we can from these three figures, we can extrapolate the following information. First, concerning the context in which the months were varied, we have that the best skill correspond to those combinations, including the summer, spring, and spring season. Concerning the dependence on the lead time, we found that the best skills belong to those combinations implying an average over a long lead time, for example, 2 to 9 years. And concerning the period, the best skill being found for simulations initialized before around the 1969 and after the 1976. So more or less the same features can be found if we analyze the skill measured with RMSE instead of ACC. So if we search in our huge three-dimensional matrix, which is the best skill, for example, ACC, and for example for lambda equal 44 years, we found that the best skill is localized by this guy, which is not a chemical formula, it's not a chemical combination, but it's just the position of this combination of this context. That is the period between 1964 and 2007, with lead time of 6 years and with months from June to September. Here is the skill over all the Europe, and if we compare with our standard configuration, we can see a general improvement, especially over Scandinavia and Western Europe, while Iberia and northeast of Europe, they are still with very low skills. So these features promoted a more regional analysis by using the same methodology. So we divided Europe in 7 boxes, and we performed the same analysis. I want to reassure you, I'm not going to plot something for all the regions, but I will just concentrate. I will just focus on the box including Iberia, that so far seemed not to have any hope of good predictability. So if we analyze the varying skill in function of periods, we can see that there is a very clear improvement for years starting from 1974, and notably for months including spring and summer interval. So the fact that that this skill improve really clearly after a certain period can suggest that there is maybe a link between the predictability of the IMV and the predictability of air temperature over Spain. I haven't checked that for the moment, so it's just a speculation for the moment, but if confirmed, we can say that possibly AMV is an emerging constraint for temperature predictability over Iberia. And so if we search again the best combination within our three-dimensional matrix, we found that over Iberia, we found this configuration. So period between 1980 and 2005 with lead time to 9 years and 4 months from March to September. And if we compare again with our reference configuration, we can see that we pass from no skill at all, from very low skill of no significant ACC over this region, to a very high skill over the world region. So to sum up, we show that the skill of the IPSL CM5 DCPP system in predicting air temperature over Europe is dependent on season, on lead time, on period, and also on the specific region considered. In particular, if you consider the Europe as well, the scale seems to vary, especially in function of the season, but also for more regional analysis. Also, the specific period can be an important factor determining the skill. So for the future, the same systematic approach can be used for different DCPP system and also for their ensemble mean, and also for other variables out of air temperature. And I want to finish to stress the importance of the detection of optimal window of opportunity in the application to impact studies, so climate service. For example, for impact studies in viticulture, for example, classically we have that climate data are coupled with phenological data that mainly run over a certain period of the year. So it means from over the growing season, so more or less between January, February, and September. And so the fact that we found very good skill exactly over that season is very good news for an effective application of decadal prediction to impact analysis. So thank you very much for your attention, and sorry for my voice. And that's all. Thank you.
Thank you very much. Okay, do we have time just for one question? Let's see if any hands go up. So far, we've not had many hands going up. The chat seems to have worked better for the questions. But Paula, can you see any? I'm not seeing any.
Freya has asked a question. Freya, do you want to repeat it?
Yeah, just had a question about when you showed the time dependency of skill and potentially linking it to the AMV. I was wondering if you don't think that part of that could be due to initial conditions potentially being better captured later on in the series, given that observations going back to 1960 might not be that great.
Yeah, this is just a speculation. Actually, the only thing that I can see is that the good skill starts when the AMV pass from a negative phase to coincide with when the AMV pass from a negative phase to a positive phase. So, and yes, the years on the y-axis is just the beginning of the simulation. And yeah, so for the moment, I just put this as a potential further development of this analysis, but I haven't checked. Even because with the bias data, I cannot calculate the AMV because watch data are just data over the land, and so I cannot extrapolate any signal of the AMV.